this is our video submission for Lab 5. Our team name is the Transistors. So here is our main.ept, the main code which has the logic. So let me explain first this PID value. This is already like covered in the Lab 2 portion. So basically the important part is the error term here. So it's left minus right, and so left sensor minus right sensor value, and the extreme sensors are being weighted by 5, and this is again a calibration constant. All the numbers that we have used over here are basically calibration numbers, so it depends from machine to machine and lighting conditions and the code also. Now coming to the main, so this is just the initial state to start the run. It's not a long one. As soon as it comes, it just remains for one cycle. Then it directly goes to the run state. This run state is basically the state to complete the white line on the black background part. So what we have used over here is basically just normal PID, and based upon the values of PID we decide what kind of movement the wheels will be doing. Like for suppose if it goes beyond the threshold, that is 25, again this is empirical, we decide that instead of moving both the wheels forward, we will do a differential mechanism, that is one wheel will move forward, other will move backwards, and which one moves forward and which one moves backward depends upon the PID values. So 2 means left turn. Now if you just see that on the left side, if there is white curve, let me show you the part over here. So basically this is the arena. So over here, if the left side there is white value, so left sensor will have higher value, therefore L1 minus R1 will be positive, so PID will be positive. So on the positive side, if it goes beyond the threshold, we will do a left turn, similarly the right turn on the other side, else 1. Now this is for the transition, because we are supposed to go from white line to black line. So again these numbers are being found empirically after a lot of experiments. So it goes into black run. Now this black run is responsible for the bot's movement on the black line against the white background. Now this is exactly same as the run state. The only difference is the signs have been interchanged, because now the line is black instead of being white, and the background is white instead of being black. Now from here we can go to actually 3 states. Basically these two have different conditions. I will explain it later. So technically there are just 2 states. One is the obstacle navigation state. Now here, as you can see, after doing this transition over here, we will go in on the black line, and we are supposed to overcome this obstacle from the right parameter. And so now for suppose not IR equals to 0, now I will explain just in a time what IR is. We will go into the obstacle state. So over here in supervisor.iono, this is the iono file which will dump on the bot, and we are not using any other sensor, we are just using what was already provided. These 2 are the IR sensors for proximity checking. Now if the output of this sensor or the register is B, that means both the sensors are detecting an obstacle, we are assigning it IR equals to 2. Similarly -1 for only left, 1 for only right, and 0 for nothing. So there are no object detection. Also let me tell you one more thing, that this is the calibration part which we have done. We have found this value by reading what are the maximum and minimum values that are
putting the vehicle on all white and then all black, and then recording the values of the sensors. We get to know the maximum and minimum of the sensor values, and then we map it to 0 to 1000, so that we are able to write better code.
So now coming back to over here, now also this D is for our own purposes, that is for debug. Now let's say we go to the obstacle state. So here obstacle state, it is also it has an automata inside of it. So init state is basically nothing, but once it detects, it stops for a while, just for 10 cycles, not 1 second. Basically the first thing it does is turn right. Now it turns right for a certain cycles. Now these cycles are equivalent to the angle it turns on the right, and this number you can get after, it depends on machine to machine, so you can get it empirically. Now it turns right, then it goes forward once t is completed. So it goes forward in this state, it goes forward for a while. Here again this number like 140, so it will go forward, then it will turn. Once it goes forward, it will turn towards the left. Now it will turn left here. It will turn left as long as we detect the obstacle on our left sensor. Then we will again go to turn right and we will turn right. So basically, like if our board, it comes and this is the obstacle over here. So it detects, it turns right, goes forward, turns left till it detects, then again turn right, goes forward, turn left till it detects, and turn right, go forward, turn left, detect, turn right, go forward, turn left, detect, turn right, go forward. So basically that way it circumvents on the right side. Now basically here comes the exit part. So once it get yeah, over here it is. So it goes outside of this OBS state, which is the obstacle navigation state. Once it recognizes a black line, that is a low value, and there are no obstacle in proximity, it will do an exit. Now coming to this state, it is nothing, it just turns towards the right till it centers itself, and then it will continue the black run, that is going on the black run. Now as you can see over here that unlike the white line, on the black line there are multiple intersection and junctions. So how do we navigate them? So quickly let me show you this state, which is increase junction counter. So JCTR is the junction counter. So it counts how many junctions we have completed, and based on the arena that we are supposed to navigate, this is the values that rotate right, rotate left, which part to take. Rotate right, rotate left are nothing but these are just 90-degree turns. Again, these values of t are being obtained experimentally. Right, left are basically the same thing except for the direction. And once it goes to the junction counter 5, it goes into the parking mode. So here you can see there are like 1, 2, 3, 4 and 5. Once it reaches the 5th corner, it goes into the parking mode. Coming over here, I said I will explain this. So over here, as you can see, these are different conditions. So basically, why have we used this? So here, if you see all these 4 junctions, there are basically like there are horizontal lines. It's not just the straight line. So the extreme sensors also detect the black line. Come over here, the sensors are aligned like this. The board will be facing this way. All the extremes will be here also, but here the line is only straight, so the extreme sensors do not detect the value. So in this case, when we are on the parking side, we do not include the R1, R2, L2, R2 values. So now coming to the parking state. So basically what we do, we just come over here, we check towards the left side. If there is obstacle, we then check towards the right side. And if both are having obstacle, we come back to the line and then we move forward. We do the same thing again and again. Now let's say we do not find an obstacle here, we park here. Here there is obstacle, here there is no obstacle. So we check, there is obstacle, turn right, no obstacle, park on the right. So here basically the code, just check left. So you turn towards the left till you detect an obstacle, that is over here. If you detect obstacle, go to check right, same thing. Do it till you detect this obstacle on the right, then back on track. Now what if you don't detect? So this is the condition, you don't detect. We have given a certain time limit, that is 100, which is actually an equivalent to how many degrees it is supposed to turn on the left. So we have this park variable which has 3 values, -1, 0, 1. -1 means it can park on the left, there is nothing on the left, there is nothing to no obstacle on the left. 1 means no obstacle on the right, you can park on right. 0 means there are obstacles on both the sides. So here if it is this, that is there are no obstacles on the left, it takes -1 value, else it will take 0. Then coming over here, again if there is nothing on the right, it will take 1 value, else 0. The logic which I explained is covered by these two steps properly. Coming to the back on track part, so basically this is nothing, depending upon which side it is, it will come back on the track, and this is the condition when it will stop, that is the black line is in the center, then it goes forward. Now forward is basically of two kind, like here you detect both the obstacle, you need to go forward till here. Now let's say you do not detect an obstacle, you want to park over here, so you don't go till here, you just go to the half point and then rotate towards the left or right, whichever one where you want to park, go up and park your vehicle. So basically this is just going forward, this PID same as black run state. Now if park is -1 or 1, we go till 400 cycles.
We're decrementing the T
Yeah,
here.
so from 1000 we go till 600, that is 400 cycle we go forward. Otherwise we go till 1000. This is again experimental, 1000 will cover a whole slot. Now park left, park right, basically if based upon park value we turn the vehicle towards that direction, 2 or 3 based upon left or right respectively. Again these numbers are experimental. Now final state, nut bolt shifu, this is our own discovery. So what we do over here, we go forward for 300 cycles, that is we go to the center of this parking lot, so there is no touching, or like we have enough space, enough margin of error properly in the middle. It goes, then it goes to P stop. P stop is basically the end state where you go and you never come out, terminal state, and you stop the vehicle. Also it will beep when we are in the P stop, that is the final. Now
So,
Rahul will
I will load the code in the vehicle. So as you can see, we have our vehicle here, and let me also open the Arduino IDE. So as you can see, there is no vehicle being detected here, and I will put in the code. So yeah, so this ensures that we are using the same vehicle as being detected here. Now I will run integrate.sh main. So this is the same main file here. So let me just run it again, and then I'll upload the code in the vehicle. As you can see, we can also see here that we are done uploading, and we can also see the vehicle also. It indicates that some code is being uploaded. So let me just do that again. So yeah, it blinks whenever we want to upload some code.
you can see the blue light on the bottom ceiling.
Yeah. So
Blue light.
as we are done uploading, let us try this vehicle.
Obstacle says basically this is our arena, and this was the obstacle which is we are supposed to circumvent from the right side, and then that is the parking lot. So we will just park over there. Those represents the obstacle, that is the parking slots are occupied. Now we will start. So wait a minute, let me just वो लाइट में दिख फिर से रन करना I guess there is some calibration issue over here, so let's just try once more time, and then let's So it also depends upon, like, if you by mistake put it elsewhere, then it might change the state. And also it depends upon the lighting a lot, because the infrared sensors are photoresistive sensors. It will try to circumnavigate. So now it has detected the black line again, and now it will move towards the parking lot. It detects there are obstacles on the both sides. Now here on this lot there are none. Now it comes and there are beep, which means successfully parked. Thank you.